Okay, I think everything's working. It's my first stream in over a year, so fingers crossed everything goes well. A little context of what we're going to do here is Flutter released these architecture documentation, basically on how to architecture a Flutter application. It's the pattern. It's called MVVM. A little context of who I am and what I do. So I'm a Flutter GDE, so I know relatively good at Flutter. I also have built a course using MVVM, but I think there are some differences with the Flutter recommended MVVM versus the MVVM that we use. So I wanted to, this is my first time going through these docs. I want to build a very simple application because the way I learn is by kind of dumbing it down all the way, like making the most simplest like use case that I can think of, trying to make it work using whatever they recommend. And that's the best way to learn. So I figured I might as well share this online. So a little context about how I think of MVVM before we really get started. So I have this within the course. We have this this workflow. So MVVM stands for model, view, and view model. That's like three different parts of. Let me hide this. Sorry if I'm sniffling a bit too. I was just got done being sick, so I'm gonna try not to sniffle, but if it happens, I apologize. So you have the view, which is what you actually see. You have the view model. Oh no, so you have the model. The model is the data. So you could think of like user data. You'd have the user model. You have username, things like that. It says my stream is currently not the best, but hopefully it's doing well. So you have the model, which is like the user data. You have the view where you would display the user data. And I realized I'm not sharing my screen. Great. So you have, and I can maybe lower this app to make it a little bit smaller. Come on. So you can see me. Nice. All right, that should be good. So you have the view, where's it's the data, so like user data or something like that. No, wrong. You have the model where it's the data, so like user data or something like that. The view where you would display that user data, and then the view model is like the connecting tissue of both of those. So the view needs to react to the data changes within the view model. And let me kind of explain a little bit if we go into the view models lesson. So within the view model, you give a value notifier, and then your UI would listen to this value notifier for any changes. And if there are some changes, then it would update the UI to match that. And also within the view, you trigger any updates. So the methods, basically all the business logic is within the view model. And then you have to trigger it using the UI and listen to it using the UI as well. Then there's a few other concepts that we have. So let me see if I could zoom in here. Nice. So these are how we define model, view model within our course. So we'll see. I know that there's a lot of similarities with the architecture docs, but there are some differences. And I think, so this course, it was built by me and Robert. Robert's kind of the more technical guy. I haven't really built anything with MVVM, but I helped write these lessons, like helped him put it into nicer words. So I should have a pretty good understanding, but just want to kind of give a little bit of context at the beginning. So the way we talk about it is we have the view model part. So this is all within each screen. Like I said, you have user data. Maybe you want to display the homepage with their username. That's what these three would do. Then you have services, which is app-wide state. They might also use models. Maybe in this case, you need the user data to be across multiple parts of the application. Then you have the repository, which takes in your data source. So maybe the user data is coming from Firebase now, or it'd go through the repository and passed into the view model. Or maybe it's needed to be used across the whole app. So it'd go through the repository and it would go into the service thing. And then the view model would ingest the service. Basically, you just want to separate everything out. Integrations, this is kind of a optional part. You can have an extra layer between all the packages to abstract the package logic away, but we don't really care about that. So that's kind of the really short, but hopefully well explained enough approach of how I use MVVM and how I think about it. So now we can go into this, and let me make this look a little nicer too. I could do this and this, perfect. And then let me extend this. So what I have right now is a basic, very basic counter application that is connected to Firebase. So we have our Firebase over here. We have the Firestore database. You see we have a value 9. If I increment it, hopefully everything works. Yeah, so it gets incremented here. This is not using any architecture. This is just the base counter application, and I want to change this to use the Flutter architecture. Make it really simple and really easy to understand. So let's get into it. I'm going to be pretty much reading through the docs and building this app. So let's settle in. Architecture is an important part of building a maintainable, resilient, and scalable Flutter app. Agreed. In this guide, you learn app architecture principles and best practices for building Flutter application. Architecture is a word that's hard to define. It's a broad term and can refer to any number of topics depending on the context. In this guide, architecture refers to how to structure, organize, and design your Flutter app in order to scale as your project requirements and team grow. So yeah, that's what I think of architecture as well. And just, I guess, a little spicy thing. There's a lot of drama around these documentations. So that's also kind of why I wanted to really take the time and go through all of it. Like, there's this issue. They wanted to replace it with a different name. And then at the end, they had to lock this conversation because it's no longer productive and careening towards nasty. It's not the place to throw around insults, and I've set a reminder to unlock this in 2 weeks, which was 2 weeks ago, so might be getting unlocked soon. Just a little extra context for why I think this is a fun stream to do. Okay, so what you'll learn through these docs. The benefits of intentional architecture, common architecture patterns, Flutter team's recommended app architecture, MVVM and state management, dependency injection, and common design patterns for writing robust Flutter apps. Look at this. We got dependency injection, MVVM recommendations, all that stuff is in here too. Benefits of intentional architecture. I don't know, maybe we don't even need to use this. Maintainable, scalable, testable, lower cognitive load, better user experience. This is a guide for building scalable Flutter applications and was written for teams that have multiple developers contributing to the same code base who are building a feature-rich application. If you're writing a Flutter app that has a growing team and a code base, this guidance is for you. Along with general architectural advice, this guide gives concrete examples of best practices and includes specific recommendations. Some libraries can be swapped out, and very large teams with a unique complexity might find that some parts don't apply. In either case, the ideas remain sound. This is the recommended way to build a Flutter app. It's a very strong stance. But from what I understand, they reached out to a bunch of other developers and teams working with Flutter, and this is what they kind of recommended. And so this kind of applies to how I understand MVVM. Like, we have the same. I think we have the very similar sentence in our own courses. Like, it's the concepts that matter. It doesn't really matter the actual library you use for dependency injections, for example. You should be able to remove it and add in new ones whenever you need. The key kind of, so Robert's kind of went through these documentations a bit, and like I said, he knows, he's worked with MVVM on massive projects with an actual big team, using the approach that we have, and the one thing he kind of found from these docs is that they seem a little bit confusing. They don't have the docs are written for very advanced users, or at least intermediate users, or we kind of have a structure where it's you can start very simple by not needing too much. You just the MVVM and some services, and you can just bring in the whatever you need right into that view model instead of having crazy abstraction. But they went to a really full-blown route, which might be a good decision. I don't know. We'll see. All right, time to get into it a little bit more. So, common architecture concepts. In this section, you'll find tried and true principles that guide architectural decisions in the large world of app development, as well as information about how they fit into Flutter specifically. It's a gentle introduction to vocabulary and concepts related to the recommended architecture and best practices, so they can be explored in more detail throughout this guide. Separation of concerns. Separation of concerns is a core principle in app development that promotes modularity and maintainability by dividing application functions into distinct self-contained units. From a high level, this means separating your UI logic from your business logic. This is often described as layered architecture. Within each layer, you should further separate your application by feature or functionality. For example, your application's authentication logic should be in a different class than the search logic. In Flutter, this applies to widgets in the UI layer as well. You should reuse lean widgets that hold as little logic as possible. So yeah, that was pretty clear. Separation of concerns. You just separate the logic within your app to make things a lot simpler. And layered architecture, which seems very similar to MVVM. Flutter applications should be written in layers. Layered architecture is a software design pattern that organizes an application into distinct layers, each with specific roles and responsibilities. Typically, applications are separated in 2 to 3 layers depending on complexity. The UI layer, the logic layer, and the data layer. So UI, to me, seems like the view. Data layer seems like the model, and logic layer seems like the view model. Displays data to users are exposed by the business logic layer and handles interactions. This is also commonly referred to as the presentation layer. The logic layer implements core business logic and facilitates interaction between the data layer and the UI layer, commonly known as a domain layer. This logic layer is optional and only needs to be implemented if your application has complex business logic that happens on the client. Many apps are only concerned with presenting data to user and allowing the user to change that data. These apps might not need this optional layer. Data layer manages interactions with data sources such as databases or platform plugins, exposes data and methods to the business logic layer. These are called layers because each layer can only communicate with the layers directly below or above it. The UI shouldn't know that the data layer exists and vice versa. So that makes sense. But I also like comparing it to what we use. The repository sounds like the data layer. Manages so this is where the confusion between what we worked with came from. I think it's this data layer. It seems like it's doing a lot. But maybe UI, logic, and data layer. So how I guess I don't get how the logic layer is optional. Because if we do the UI, the data layer, the logic layer is a view model, and then the data layer is a repository. So maybe he's talking about these 3 sections. Let's keep going. Every data type in your app should have a single source of truth. It's true. The source of truth is responsible for representing local or remote state. If the data can be modified in the app, the source of truth class should be the only class that can do so. Yes, very true. And that's exactly why we have this. So if you're using something from the repository, this is the source of truth. If you have app white state, you use a service, and that's your source of truth. So if it's like if you only need to, let's say you have some random checkbox that only needs to be seen within the page, within the view, then your view model will have a value notifier that's the source of truth. And same with like the integrations. This can dramatically reduce the amount of bugs in your application, and it can simply code because you'll only have one copy of the same data. It can simplify code. That's a spelling mistake because you'll only ever have one copy of the same data. Generally, the source of truth for any given type of data in your application is held in a class called repository, which is part of the data layer. There's typically one repository class for each type of data in your app. So I think this is part where it gets a little confusing for me. The source of truth for any given app is held in a class called repository. So here, somewhere they mentioned repository or the data layer. So I see the data layer as the repository. And then they say the single source of truth can be within the application too. If the data should be like, there should only be one class in there that could be updated. So to me, single source of truth is not just a repository. It can be a repository, it can be the service, or it can be the view model. Just depends how broad the data needs to be reached. The principle can be applied across layers and components in your application as well as within individual classes. For example, a Dart class might use getters to derive values from a single source of truth instead of having multiple fields that need to be updated independently, or a list of records to group related values instead of parallel lists whose indices might get out of sync. This example seems a little, I don't know, it didn't read nice, but yeah, using getters, you should use getters from your single source of truth instead of, grabbing them directly. Unidirectional data flow refers to a design pattern that helps decouple state from the UI that displays that state. In the simplest terms, state flows from the data layer through the logic layer and eventually to the widget in the UI layer. Events from the user interaction flow the opposite direction, from the presentation layer back through the logic layer to the data layer. So I agree, but that's very, very specific to data coming from a repository. Like, for example, where you have a to-do application, right? The to-dos, they come from the repository. They come from the repository. You consume them in the view model, and you pass them to the view. That's great. But then we have a button that says Hi to-dos. That does not need anything tied to a database whatsoever. You just click the Hi to-dos. You either show the ones that are done, or you don't show the ones that are done. The source of truth for whether it should be hidden or not is directly in the view model. Okay, keep going. In UDF, the update loop from user interaction to re-rendering the UI looks like this. So this is an example. An event occurs due to the user interaction, such as a button being clicked. The widget's event handler callback invokes a method exposed by the class in the logic layer. So using the to-do example, you click add a to-do. In the view model, you get triggered that you need to update, like add a to-do layer. So then the logic layer calls the method that exposed by a repository that know how to mutate the data. So again, yeah, you in that place you call the repository data, the repository function. So Firebase update the to-do item or add new to-do. The data layer, the repository updates data if necessary, then provides a new data to the logic class. Correct. So the view model should be listening to a stream exposed by the repository, so it's always up to date. The logic class saves its new state, which it sends to the UI. The UI displays a new state to the view model. Yeah. New data can also start at the data layer. For example, a repository might pull HTTP server for new data. In this case, the data flow only makes the second half of the journey. Yeah, because it's not an interaction from the user, it's just new data coming in. In this case, the data flow only makes the second half of the journey. The most important idea is that data changes always happen in the single source of truth, which is in the data layer. This makes your code easier to understand, less error prone, and prevents malformed or unexpected data from being created. Yeah, that sounds good. Oh, that sounds good. UI is a function of immutable state. Flutter is declarative, which meaning that it builds its UI to reflect the current state of your application. When state changes, your app should trigger a rebuild of UI depends on the state. In Flutter, you'll often hear this described as UI is a function of state. It's crucial that your data drive your UI. It's not the other way around. Data should be immutable and persistent, and views should contain as little logic as possible. This minimizes the possibility of data being lost when the app is closed and your app more testable and resilient to bugs. This is like the crucial part about why you want to make sure you're using an architecture. Like this sentence right here. I guess not an architecture, but an architecture kind of makes you do this. Okay. Extensibility. Each piece of architecture should have a well-defined list of inputs and outputs. Each piece of architecture should have a well-defined list of inputs and outputs. Right. For example, a view model in the logic layer should only take in data sources and inputs, such as repositories, and should only expose commands and data formatted for views. This is where we differ. like, while yes, that can be a truth, what about app state? I think that's where the disconnect kind of happens. If you have app wide state, that's where you need this service. Or maybe you have a package. Maybe packages could go through the repository, but that's just like a kind of a naming convention, right? The repository integration could be named the same thing, theoretically. But yeah, I don't know. That's something to think about. So I disagree with this part. I'm kind of curious about, like they say in the introduction, right? This is going to be MVVM and state management. So from what I've read so far, it's there's no state management yet. Okay, using clean interfaces in this way allows you to swap out concrete implementations of your class without needing to change any code that consumes the interface. Testability. The principle that makes software extensible also makes software easier to test. For example, you can test the self-contained logic of a view model by mocking a repository. The view model tests don't require you to mock other parts of your application. You can test your UI logic separate from the Flutter widget itself. Your app will also be more flexible. It will be straightforward, low risk to add new logic and new UI. For example, adding a new view model cannot break any logic from the data or business logic layers. The next section explains the idea of inputs and outputs for any given component in your application's architecture. Okay, I think a lot of this makes sense. Like I said, there's just one missing piece. It's the app-wide state. So this is where we get deep into it. Oh, yeah. So I think in the data layer, from what I quickly checked, it seemed like the services. I don't know. Actually, we'll get to it. Let's go in order, so I don't miss anything. Get some water again. All right. The following pages demonstrate how to build an app using best practices. The recommendation in this guide can be applied to most apps, making them easier to scale, test, and maintain. However, they're guidelines, not steadfast rules, and you should adapt them to your unique requirements. This section provides a high-level view of how Flutter applications can be architected. It explains the layers of an application along with the classes that exist within each layer. The section after this provides concrete code examples and walks through a Flutter application that's implemented these recommendations. Oh, they already did it. Well, we're going to do it too with a simpler application probably. Overview of project structure. Separation of concerns is the most important principle to follow when designing your Flutter app. Your Flutter application should split into two broad layers, the UI and the data layer. Each layer is further split into different components, each of which has direct responsibilities and well-defined interface boundaries and dependencies. This guide recommends you split your application into the following components: view models, repositories, and services. If you've encountered the view model design pattern, this will be familiar. MVVM is a design pattern that separates a feature of an application into three parts: model, view model, and the view. Views and view models make up the UI layer of the application. Repositories and services represent the data of the application, or the model layer of MVVM. Each of these components is defined in the next section. Well, let me kind of think about this. The model layer. Maybe that's where the disconnect is. The model, I see it as the actual data definition and where you can manipulate, for example, like the user model. The repository uses that model for sure. I can use it, but it's not the model itself. Let's keep going. Every feature in an application will contain one view to describe the UI and one view to handle logic. One or more repositories as the source of truth for your application, and 0 or more services that interact with external APIs like client servers and platform plugins. A single feature of an application might require all of the following. So the view displays data and listens for events. The view model handles view logic. So like, I don't know, repository A, caching and retry logic error handling with service 1. API pull data. Method channels and native objects. HTTP. Caching and retry logic. So this part is where the confusion comes from. We have this right here. They only talk about this route: view model, then a repository, and I think their service is our data source. Which I don't know. I like the word data source better, maybe, but I'm probably biased. But like, where the data is coming from. Method channels and native objects. So they definitely have, don't separate this. They have the repository part of, like the integration is part of the repository. So this can be combined as one thing. So if they're getting stuff from the packages from the camera or something, it just goes through the repository. Which I like our naming a little bit better, but I'm not going to judge too much about it. But my issue is, where is the app state? There's no app state here. Everything is coming from a service. Like one little example, let's say you want the current date in your application somewhere. You can just get that directly from Flutter. You get the current date, and then you can display that date. And you can display many parts. Or you only want data, you don't need to connect to any server or anything. You want to just hold data for that session. Maybe, I don't know, this counter application, maybe we don't want to actually store it in the application. We just want a fun little counter, and we want it to be visible from different parts of the application. Yeah, I think that's going to be the confusing part. Each of these objects and the arrows that connect them will be explained thoroughly by the end of this page. Throughout this guide, the following simplified version of the diagram will be used as an anchor. Once again, no app state. Like in this case, you don't need state management really, because you just listen to the service and you just pass it down. There's no need for any state management. After complex logic might also have a logic layer that sits in between the UI and the data layer. This logic layer is commonly called the domain layer. The domain layer contains additional components called often interactors or use cases. The domain layer is covered later in this guide. We'll see. An application's UI is responsible for interacting with the user. It displays an application's data to the user and receives user inputs such as tap events and form inputs. The UI reacts to the data. Maybe we could go through this a little faster. Like I think we understand. I understand at least the view. Reacts to data or the user inputs. When the UI receives new data from a repository, it should render that data. When the user interacts with the UI, it should change to reflect that information. Yeah. The UI is made up of two architectural components based on the MVVM. Views describe how to present the application data to the user. Specifically, it refers to a composition of widgets that make a feature. For instance, a view is often but not always a screen that has a scaffold widget. Along with all the widgets below it in the widget tree, views are responsible for passing events to the view model in response to their interaction. View models contain logic that converts the app state into UI state, because data from the repositories is often formatted differently from data that needs to be displayed. For example, you might need to combine data from multiple repositories, or you might want to filter a list of data records. Yeah, views and view models should have a one-to-one relationship. So the view model is directly holding the data for that view. It's very clear. In the simplest terms, a view model manages the UI state and the view displays that state. Using views and view models, your UI can maintain state during the configuration changes such as screen rotations. You can test the logic of your UI independently of Flutter widgets. Yep. View is an abstract term. One view doesn't equal one widget. Widgets are composable. Several can be combined to create one view. Therefore, view models don't have a one-to-one relationship with widgets, but rather a one-to-one relationship with a collection of widgets. A feature of an application is user-centric and therefore defined by the UI layer. Every instance of a pair of view and view model defines one feature in your application. This is often a screen in your app, but doesn't have to be. For example, consider logging in and out. Logging in is generally done on a specific screen whose only purpose is to provide the user with a way to log in. In the application code, the login screen will be made up of a login view model class and a login view class. On the other hand, logging out of an app is generally not done on a dedicated screen. The ability to log out is generally presented to the user as a button in the menu. On the other hand, the logging out of an app is generally not done on a dedicated screen. The ability to log out is generally presented to the user as a button in a menu a user account screen, or a number of different locations. It's often presented in multiple locations. In that scenario, you might have a logout view model and a logout view, which only contains a single button that can be dropped into widgets. Okay, I think I'm starting to understand. So what they talked about here, I would define as a service. Like you have something that can be connected to any part of the application. So it can be on multiple screens. It can be in a menu, in your user account screen, or a number of different locations. This point right here. So then if it can be in many different locations, okay, it still is one-to-one with a login view. That's interesting. So then they have, like I kind of associate a view with a page almost. Like, yes, it can be a widget or a collection of widgets, but most of the time it's a page. So you have the login screen. The login screen would have a login view model where you would have the state of what they're typing in and everything. And on a successful like login, you would get rid of that view model, you get rid of that login screen, and now you would have a new service of user information. Like, does the login view model contain the user data here too? And you just keep it around, it's just a massive view model? Maybe. Like, I could see how that would work, but just seems confusing. And again, we still have the situation of app white state. Like, I mean, I can't really think of a good example right now, but like maybe a user wants to change his username just for that session. It doesn't need to be sent to any backend. Would you keep that in the login view model? That doesn't sound right. It's often presented in multiple locations. In that scenario, you might have a logout view model and a logout view, which only contains a single button that can be dropped into your widgets. Yeah, so that's definitely what they're doing. When you log in, you might have the login view, gets triggered, and then a new view model, what we would call a service, gets created. But we don't really tie, like it has a one-to-one tie to the logout button. I'm trying to think if I like that or not. Like what are some arguments for it? It definitely seems like it definitely works, right? There's nothing wrong with it. Like if this is how you prefer to write, then this definitely works. Like I mean, obviously, like the Flutter team didn't put out something that doesn't work. But to me, it doesn't seem as nice as having like an app white state. Now, let's get going. I'm not going to get too drawn up on that. But this is where the key, I think, differentiation is. Views. In Flutter, views are the widget classes of our application. Views are the primary method of rendering UI and shouldn't contain any business logic. They should be passed all the data they need to render from the view model. The only logic a view should contain is simple if statements to show and hide widget based on a flag or nullable field in the view model, animation logic, layout logic based on device information, simple routing logic. All logic related to data should be handled in the view model. Yep. View model exposes the application data necessary to render a view. In the architecture design described on this page, most of the logic in your Flutter application lives in the view model. A view model's main responsibilities include retrieving application data from repositories, transforming it into a format suitable for presentation in the view. For example, it might filter, sort, or aggregate data. Maintain the current state needed in the view so that the view can rebuild without losing data. For example, it might contain Boolean flags or conditional render widgets in the view, or a field that tracks which section of the carousel is active on the screen. Expose callbacks, called commands, to the view that can be attached to an event handler, like a button press or a form submission. Commands are named for the command pattern and are Dart functions that allow the views to execute complex logic without knowledge of its implementation. Let's see, what is this link? Took me there. The command pattern is a behavior design pattern which an object is used to encapsulate all information needed to perform an action trigger. Sure. A lot of this naming stuff, I'm like, oh yeah. I guess it's good to have a name attached to it. Whatever. You can find examples of view models, and commands on the UI logic portion of the architecture case study. For a gentle introduction to MVVM and Flutter, check out State Management Fundamentals. Managing state of Flutter. Showing state between widgets. Wait, where's the using MVVM for architecture's application state? Defining the model. Again, they're using, it's coming from a data source, which is like fine. But what if we want this counter just within the application? I think that's normal. That's unless that's like a thing people don't do. Like, I mean, a lot of your data should be stored somewhere, but some of them just don't need to be. Okay, data layer. The data layer of the app handles your business data and logic. Two pieces of architecture make up the data layer: services and repositories. These pieces should have well-defined inputs and outputs to specify their reusability and testability. Using MVVM language, service, and repositories make up your model layer. Repository classes are the source of truth for your model data. They're responsible for pulling data from services and transforming that raw data into domain models. Domain models represent the data that the applications need, formatted in a way for your view model class can consume. There should be a repository class for each different type of data handled in your app. Repositories handle the business logic associated with services like caching, error handling, retry logic, refresh data pulling services for new data, refreshing data based on the user action. So they call services anything that's outside the application. We call services the app state. And we're like, we could change this naming, but like that kind of, like I said, the naming for me doesn't really matter. It's just to be able to understand how things work. And for me, like, I still don't get how they do app state. It seems like they just don't have app state. I don't know. Repositories output applications as domain models. For example, a social media app might have user profile repository class that exposes a stream user profile, which emits a new value whether the user signs in or out. Thank you, everybody. I just checked the chat for the first time in a bit. Everybody's saying hi. Mitch, thanks for the good vibes. Robert's here. Everybody, good time. So the model outputs by repositories are consumed by view models. Repositories and view models have a many-to-many relationship. A view model can use many repositories to get the data it needs, and a repository can be used by many view models. Model outputs by repositories consumed by view models have many-to-many relationship. Yes. A view model can use many repositories to get the data it needs. Yes. And a repository can be used by many view models. Yeah. Repositories should never be aware of each other. Yes. If an application has business logic that needs data from two repositories, you combine the data in the view model or in the domain layer, especially if your repository to view model relationship is complex. Services are in the lowest layer of your application. They wrap API endpoints and expose asynchronous responses such as future and stream objects. They only use to isolate data loading. They hold no state. Your app should have one service class per data source. Examples of endpoints that services might wrap include the underlying platform like iOS, Android APIs, REST endpoints, local files. As a rule of thumb, services are most helpful when the necessary data lives outside of your application's dark code. This is true of each of the preceding examples. Services and repositories have many-to-many relationship. A single repository can use several services, and a service can be used by multiple repositories. Hold on. That's a bit confusing. So Firebase can be used by multiple repositories. Let's think about that. So you have your data source. which is Firebase. Okay, yeah. Okay, that makes sense. So you have like your user repository, and then you have your to-dos repository. You can use the same Firebase data source. Yep. A service can be used by multiple repositories. A single repository can use several services. Yeah, okay. That makes sense too. Because let's say, I don't know, a user, you want to use the Firebase auth service, and then you also want to check the Firestore service. And that's two services checking to make sure they're a good user in your application. I think so that makes sense that they do it. But I think I don't fully know, but I'm kind of thinking of the repository would be like one thing, and like for example, the user example would be an app-wide state. If it's not app-wide, it's just within the view model. So from the repository, you'd have a Firebase auth repository. So they were tied one-to-one. You'd have a Firebase auth repository where all the authentication actions are happening. And if it's an app-wide user, within the service, you check the auth and you check the Firestore. And then there you determine where they have it within the repository, which is like, again, it's fine. My still issue that I haven't really seen solved anywhere is where does the app-wide state live? Can view models be aware of each other? No, they cannot. The view models are only aware of the view, and they ingest any resources they need, and they're always tied to one view. So this is a little different, but it's again, you don't want to. I don't care about being too picky of like, oh, my way's better, this way's better. Like all this stuff works, right? It's just how you can think about it better to make it useful for yourself, so you can build better apps. But my only issue still is there's no app-wide state. Optional domain layer. As your app grows and adds features, you may need to abstract away logic that adds too much complexity to your view models. These classes are often called interactors or use cases. Use cases are responsible for making interactions between UI and data layers simpler and more reusable. They take data from repositories and make it suitable from the UI layer. Use cases are primarily used to encapsulate business logic that would otherwise live in a view model and meet one or more of the following conditions. It requires merging data from multiple repositories. It's just really complex. The logic is reused by different view models. This layer is optional because not all applications or features within an application have these requirements. If you suspect your application would benefit from this additional layer, consider the pros and cons. So is this the state management part? But they don't mention any state management. They just say if your logic is too complex. Data access with use cases. Like this, they're saying it can be used by multiple models. So it doesn't seem like a app-wide state yet. It seems like how they said they combine the data source, and you can a repository can use multiple data sources. So the Firebase auth and the Firestore can be in one repository. If that gets too complex, you can have another layer, which I don't know, seems even more complex. Data access with use cases. Another consideration when adding a domain layer is whether view models will continue to have access to repository data directly, or if you'll enforce view models to go through use cases to get to their data. Put another way, will you add use cases as you need them? Perhaps when you notice repeated logic in your view models, or will you create a use case each time a view model needs data, even if the logic in the use case is simple? Perhaps when you notice repeated logic in the view models, well, you'd use app-wide state for that, I think. If you choose to do the latter, it intensifies the earlier outlined pros and cons. Your application code will be extremely modular and testable, but also adds a significant amount of unnecessary overhead. A good approach is to add use cases only when needed. If you find that your view models are accessing data through use cases most of the time, you can refactor your code to utilize use cases exclusively. An example app used later in this guide uses use cases for some features, but also has view models that interact with repositories directly. A complex feature may ultimately end up looking like this. Yeah, this is where, like, I get it, but it's just like adding complications to something and still not solving app-wide state that doesn't need to be connected to a repository or service. Or it can be connected to a repository or service, but like doesn't have to be. This method of adding use cases is defined by the following rules. Use cases depend on repositories. Use cases and repositories have a many-to-many relationship. View models depend on one or more use cases and one or more repositories. This method of using use cases ends up looking like a layered lasagna, more like a plated dinner with two main UIs and data layers, and a side domain layer. Use cases are just utility classes that have well-defined inputs and outputs. This approach is flexible and extendable, but requires great diligence to maintain order. I just thought of a great example. Let's go to to-dos app. Do I have a screenshot? Final result. Yeah. Okay. So we have this to-do application. This is the one we would build in the course using MVVM. So we have this to-do application. We have the time up here. This is a service. And I'm thinking about like this hide or show done button. Let's say you had to-dos on different pages of your application. You always want the app to start with the hide done, right? You only want to show done while you're within the app experience. So this is an app-wide state that you want to keep, but it has no reason to be touching any database. You don't need it to be anything outside there. From everything I've read, there's no place to put this. There's like, this is a feature that you just do not have in your application. Like you can, because view models cannot talk to view models. That's like very clearly stated. And I mean, it's true. That's not how they should be done. Maintaining view models. Where is it? I think up here somewhere. I don't know. I remember logic from you guys. Yeah. Using view models have a one-to-one relationship. I remember, right? I remember reading that view models shouldn't talk to each other. One view is tied to a view model is tied to one view. Two view, it's no view model to view model tying. So in order to have something like a show or hide button, if you have two different views, for example, a home page or a second page where you want to also see the same to-dos, maybe they're filtered a little differently, but you still want that state of show done or hide done. You just don't have that feature ability. You either have to, I guess the only way you can have that feature is to be able to store it on a database somewhere using a repository and service. Like, I mean, locally, wherever, store it somewhere. That's the only way you can have that feature using this approach. I mean, I'm missing something, but I don't think I am. Like, the flow goes like this. If your app doesn't need this part, you're screwed. Let's continue. So architecture case study. All right, this is where we're going to start building our own app as well. Code examples in this guide are from the Compass sample application. Robert said, I think they would store the app state in the repository, but they don't really mention it exactly. But the repository is supposed to be tied to a service as well. So like yeah, I think that's what they would do. But to me, that doesn't seem as simple. Again, like, it works. But this is where a lot of the confusion for me comes from. The code examples in this guide are from the Compass sample application. Application that helps user build book itineraries for trips. A robust application with many features, routes, and screens. The app communicates with HTTP servers, has development and production environments, includes brand-specific styling, contains high test coverage. In these ways and more, it simulates a real-world feature-rich Flutter application. Yeah, there's a It's probably going to be a pretty big app. Maybe we don't even want to. Oh gosh. Look at this. This does not look fun. I appreciate the in-depth example, but UI, core UI, like this folder structure looks confusing. UI, core UI, shared widgets, feature name. Oh, wait, hold on. Okay, so they have UI, they have the core UI, like things that are shared, and then they have a folder by feature here. We just have folder by feature for the whole thing. Or you start with folder by feature here, and then we have a like the core or something right there. So domain, models, data, repository, service, models, config utils, main staging. I guess we could like from reading these, we don't have to go through this whole like pretty complicated app. I'm just curious. Yeah, there's no. Let's see if there's any app-wide state they would want to hold here. I guess current trips that you're planning. Like the current. Yeah, I guess you'd want to have a backup of whatever you're in progress planning. You want to have a backup of that somewhere. But let's see the data layer. Define a service. Client-facing. Content API model, destination API model, activity API model. Delete booking. Define a repository. Create booking, get booking. Yep, that looks fine. Element versus staging. Domain models. Okay. Complete the event cycle. Yeah. Dependency injection. Service. Auth repository. So you're injecting the service into there. Okay, so that's where they use the state management, is to inject services into this. All right, let's go. Let's build this application using what we've learned from MVVM. So let's go back to guide of architecture, because I don't want to go through all those. Maybe we'll end with recommendations. Oh no, these are kind of boring. All right, let's try to do this. So first, you'd have a file view.dart. What we do is we separate a folder by feature. They do it a little differently, but we'll just do this home. Yeah, call this home, and change this to home view. New file, home view model. Okay. And let's try to kind of simulate what they're doing a bit. Oh, and then actually new file, counter repository, and then new file would have Firestore service. Class counter repository, imports the Firestore service. Class Firestore service, Firebase Firestore. Bring that in. Okay. Bring that in. Okay. And then the view model, home view model takes in the counter repository. Okay, and then the home view, we can take all of this, paste it here, import package. We'll slowly, well, let's have it working first, and then we'll remove this slowly. Okay, so I think everything should still be working fine. It gets updated there. We go to our console 13. Okay. So let's start with the model. So this, the repository and the service are the model. So how do they define the actual data? Let's go back to this overview. So feature, view model, domains, domain layer. But they said they don't use a domain layer. So the data layer, like the domain layer is optional if your app gets really complex. The data layer has repositories, services, and models. API model class. Okay, so let's make this a little bit better. Data, counter repository, Firestore service, and a Firestore counter model.dart. Class Firestore counter model is the value. Yeah. So here you'd have let's see if that's right. God, AI is so nice sometimes. But you get the counter for an ID. Our ID is just defined we have a very simple ID, which is just defined as main counter. So within the counters collection, we have an ID of main underscore counter, and we get that counter. So we first need to get the counter, or we should be streaming the counter actually. So this did get it wrong. Stream the counter. Stream counter. Snapshots, yeah. You get the counters with the main counter. Snapshots.map. Return a value as an integer. So that's right. Then you want to update counter with the value. Yep. That looks right. Update the value with value. Right. All right. So in the repository. So I think this is where we defer a bit. It's like, all right, the home view. Let's bring this in. Let's final home view model. And initialize it too. What's going on here? So in our view model, we need a counter repository, and our counter repository needs a Firestore service. So home view model, home view, we create a Firestore instance here. No, that's not right. So in the counter repository, we pass a hue model, and then our counter repository is passing a service. We don't want to pass it in. Yeah, there you go. That's what we want. So we want to instantiate a new Firestore service if there isn't one. Or just, yeah, whenever this repository gets created, you want to create a Firestore service. So in the home view, yep, that's all good. So the counter repository has a service, and then you have increment counter, update counter with ID 1. You have stream counter, which is just streaming the same counter. Like this is an extra step from architecture. Like this is not putting stuff together. You're putting the data together either in the view model or in the service. So now increment counter. Like you would need the current counter value. If you go to this increment counter, main counter, Firestore counter model. We're just doing a lot of things. So here you would actually have a value notifier of the current counter. So value notifier is used to actually let the UI know that something has changed. You can use change notifier or value notifier. So now here, counter value is the stream. Let me think. Let me open up another project to see how I did it here. Oop. MVVM. I'll go through an example later of how we do it. So to do page view model. So you start off. So you would pass down the view model that's from the service. And from a database. Oh, I'm going to keep a database right now. I had a better example. In here. All right. No, wrong pull request. It broke. Hello? We had this MVVM architecture here. We had a big example with as if we used a repository layer. So to do page view model, start off with 0 and you'd have a stream subscription. Right. Then you have an init function where you set that subscription. Non-complete to-dos, subscription. Subscribe to stream from counter repository on init. Thank you. Apply. Accept. Stream subscription. Get counter stream. Get counter stream isn't defined for counter repository because it's something different. Stream counter. Main counter. Counter.value equals counter model. So yeah, you listen to the stream, you set the value to this. Then you need to make sure to dispose it already. Nice, it did that. So then we need to run this on initialization, right? Or we call it initialize counter. So home view. So we have the view model. We init state here. We dispose it and we init by doing view model initialize counter. Did we not? Why is this? Oh, okay. Yeah, it happens when you create it. Never mind. Don't need to do that. You still should dispose of the view model. Well, technically, this is actually something we talked about a bunch. You technically don't really need to dispose it because it gets garbage collected. But if you want to be safe, you can dispose it. All right, so let's start doing this. So we can delete this. We don't need the increment counter function anymore. We don't need this. We don't need stream builder. This all gets handled. The on press should be a view model increment counter. And here we do a value listenable builder that listens to the counter value, shows the counter value with the text. Everything worked on the first try? No way. 14, 15. Yeah, damn. Look at that. Look at AI go. So yeah, we don't need counter ID anywhere. So this is, I mean, you see, this is a very clear example using their structure from how Flutter docs kind of recommend you do MVVM. There might be, if I was to nitpick this from their point of view, there might be something not perfect here. Firestore service. Hold on. Save. And hot restart. It works. Something seems a little fishy here. So we have the Firestore service updates the value to the value. And when I call update counter, I pass in 1. Let's try this again. Oh, okay, yeah. Okay. That's why it doesn't work. Home view. My home page, no. My home page. Okay, that didn't make sense for a second. It should just update the value to 1 every time if it works right. So what you would do here in the counter repository, so you don't store any data here. So you store it in the view model. We have the counter value here whenever we need it. So in here you would increment the counter. Okay, so 7. So now when we click it, it should be 1. Okay, so that's working. So we have the counter value here. We would need to pass in, this needs to be updated. Stream counter, no, increment counter, ID, value, pass in the value, and the home view model, we update this to be not 1. We do counter value dot value plus 1. Isn't it just this? Counter value, because it's a value notifier. So let's do some print counter value. So counter is the value notifier that you listen to. Counter value, shouldn't that be the number? Increment counter. Instance of Firebase. Oh, okay, gotcha. So this value is the Firebase as our model. So it's our model, so the value of that, like the name model, maybe we change this to counter value. Save that. Just to make sure. And here would be counter value. Counter value. Right? Did I not save it? Oh, just counter. Counter. Okay. What's wrong? Firestore counter value. Firestore get value. Snapshot get value as int. Oh, okay, because it's we need to change this. So that value was tied to this field. All right, screw it. I'm going back. So that name value is tied to the word value within here. So we'll just remember that's where we get this value from. All right, so now looking at this is, like I said, it's fine. It works, right? Everything works. But to me, this is, well, slightly more complicated than it needs to be. To me, the repository should be doing these things. They should be, the repository is the one in charge of making sure that data is in the right format, making sure you're combining multiple services. Like the service here should be stream counter just the snapshots, I think. But you kind of have to do that now. So maybe that is how I would do it here from the data end. And the repository you would handle, like let's say you would handle failures here. So then you would get some, you would have some try catch. If something goes wrong, maybe you want to, I guess this doesn't really make sense, but you want, because this has a void return, but here, let's see if we return the counter value. I want to try catch. If this happens, we return the stream ID. If this, we return a stream of value with 0, right? If something wrong happens here. So you handle the error logic here, where this is just the tying to the actual database. And you return the function. Yeah, I could see how this is fine. I think this is in our approach, we just call this the data source. Where is it? And so this service that they have is our data source. And then the repository takes in the data source and doesn't hold any values. It just puts the data together however you need and sends it to either the service or the view model. I mean, it's pretty similar to what we do. I think a big difference is we do a lot of folder by feature right from the root. The root folder, they do folder by feature within a UI folder, which is, I don't know, it's fine, I guess. It's just folder layouts, doesn't really matter. You can control P and switch to whatever folder you want. So this is fine. One thing I would change though, one question I still have after all of this is, what do you do with app wide state? I don't think they should be in repositories. Let's go to the repository section again. Should it store any state? repository or class are a source of truth for your model data. They're responsible for pulling data from the services, transferring that data into domain models. Domain models represent that data that the application needs, formatted in a way for your view model class to consume. There should be a repository class for each type of data handled in your application. Repositories output application data as domains. Yeah, they output application data as domain models. They don't store or hold the data. Which exposes a stream, which emits a new value when user signs in or out. Models output by repositories are consumed by view models. Repositories and view models have a many-to-many relationship. A view model can use many repositories to get the data it needs, and a repository can be used by many view models. Repositories should never be aware of each other. If your application has business logic that needs data from two repositories, you should combine the data in the view model or domain layer. So the last message Robert had is I think they would store app state in the repository, but they don't mention. I think they almost directly mention that they don't do that. Repositories should never be aware of each other. So where's the app state? I don't get it. I don't get it. Like here, okay, so in this example, for like if you want this counter to be on 10 different pages, I don't feel like doing it, but like let's say you want it to be on like 10 different pages, you would just listen to the 10 different pages and you would call this update counter. Since it's a stream, you would have the most, like your source of truth is the repository. The repository, I guess. This is your source of truth. The stream, I guess your service is a source of truth, really, not the repository. Source of truth is there, and then you would have all the up-to-date, and you can click it on multiple pages, and it's all synced up because it's listening to the database. That's fine. But what if you don't want this counter to be on a database? What if you just want it for this session? You have to store it in local data or something. I don't know. I like ours better. All right, I can take you through a little example of a to-do app with our structure. So the other thing I think the docs could do better is they go 0 to 100, right? There's no like middle ground of how a very simple app with a view model should work, which is maybe fine because you don't really worry about this when you're having a simple app. We might need another view model for apps that is not bound to a view. That's against their thing. Views and view models should have a one-to-one relationship, and that's part of the MVVM structure. Is a view and a view model should always be bound together. So I don't know. Still confused. So let me show you a small example. So the thing I like about how we think about this. So again, like also it's very similar. Doesn't matter what architecture you use. I mean, it matters a little bit, right? The only thing that matters is to help you build your projects better. So whatever makes sense the most to you, you feel free and you use that. We don't really care. But I can show you how we do something. So I don't think this unit needs to be here. So what we have is, this is for a to-do app. You have, so this one is not connected to any database. So that's this big, like, kind of caveat here. So this is like a much simpler version where your to-dos are stored on one page, but we also have the app-wide state of a counter, of a date. So this is our to-do model. You have this defined. You have a to-do page that ingests your view model, and then you pass in a service. For us, a service is app-wide state. For Flutter's MVVM, a service is something outside of the app. So there's key differentiation there. So we pass in, you ingest it here, using this locator is using the get it package. It's just a way to inject something. And in their example, they used provider. Again, it doesn't really matter. And they're using provider. Where are they using provider? they're using provider somewhere. Data layer, I think it was. Get booking. What? I literally remember seeing it a second ago. So it was here. Dependency injection. Yeah. So for that, they're using provider. And send multiple fires. We're just using get it. Again, you can use whatever you want. It's just getting the data where you need it. So you have this. You again inject it same way we did with value listenable. This is just a special. You can listen to 3 things instead of 1 that we made. It's not something that needs to be discussed too much. So then you have the view model. We pass in the service. The service has its own value notifier. So in the view model, you're tied to the view. The service has its own data. So we've used the example multiple times of having a counter that you can use across the app. You would just pass in that value notifier through your view model to the view. Then we have the to-dos. We have show completed to-dos notifier. Like in the example, if we built this out to have a repository, this would come from the repository. This would be the stream of your to-dos. But then there's no reason for this to be in a database. You always want to not show them, and then whenever you show them just within the view model, you update it. You have your functions, add, toggle, done, all this. To me, and then like in the date service, again, you have app-wide state of this date. You can reset the date. And it's pretty straightforward. Then the only difference here is like if we were to add on to this, right? We would change this to-dos notifier to listen to a counter repository or like a to-dos repository. And then like the way I would name this is Firestore data source. This would be a Firestore data source instead of service. And then for app-wide state, we would use the word service. Again, they're pretty similar. I think these docs could have been I think the difficulty here is I don't see any talk about state management. Like it says MVVM and state management. I didn't see any state being managed here. Maybe optimistic state. No, optimistic state is still coming from a repository. You just kind of you assume like a positive, like let's say you trigger the subscribe button, for example, or to do even plus, you can set the UI to be updated with the new value before you get the response from the database. But then you would check it, yeah, like here. So in this example, they click on the subscribe, they set it to green, but then from the database it comes back that it was bad. They're like, oh, it actually failed. But most of the time it shouldn't fail, right? And your app seems like more snappy. Persistent storage, offline first. Yeah, I don't see any talk about state management. And the recommendation, separation of concerns, handling data. Dependency injection. Nothing. Well, if anybody from the Flutter team or anybody that has read this and understood it better knows what they do with managing app-wide state, I'd love a comment. But that part is, I buy everything else they did except for that part. I think they still, the documentation seem a little overcomplicated, but maybe that's, again, a good thing because only people that are deep into it, like for example, I wasn't able to understand it, right? I think that's a good testament to like it's fine. Documentation is fine. If I was slow and went through this case study, might be even better understanding. But I get what they're doing here. Most of it is fine. Just don't get where app-wide state comes from, and I disagree with the naming a bit. I like the naming of app-wide state as services and where the data is coming from as the data source. But for them, they also integrate the integrations and stuff. So maybe service is fine. Maybe I don't really care about that. Yeah, that's it. I guess we did it. I understand the docs a good amount. In terms of the naming, I still don't really. I feel like it's just a name. Some people are really heated about it. I feel like it doesn't really matter. But we'll use, like, again, I think a lot of this is you take pieces as you need them. If they decide to change the name to something, we'll probably update our course to that name. Seems like the thing we're actually doing is almost the very same thing, except we have app-wide state in there. But yeah, this was fun. Thank you everybody that joined. Hopefully, I tried to make this easy to watch later on, where I wasn't just thinking too much quietly. So hopefully this video can live on forever, and maybe a Flutter team member can see this and tell me where I am missing this app-wide state thing, because I do not get that part. But yeah, thanks for watching. Make sure to subscribe and do that stuff. If you want to check out the course, go to hungermind.com and you'll see the landing page and everything. Go to hungermind.com and you should see this nice landing page that we've been working on for a while. Look at that. You can build anything with Flutter. Thank you for watching. Bye-bye. Bye-bye. End the stream. Your stream will stop immediately. Yeah. End it.